Okay, so the problem I chose relates to 3.5, the chapter 3.5, regarding maximizing area, optimizing area. And I made up a problem that was kind of similar to a notes problem, but I just changed a bunch of information so I could still have to figure out, what the maximum area is. So my problem is, say you have 350 feet of invisible fence wire, and you need to lay it in a rectangle along one side of your house. If your goal is to maximize the amount of space your dog gets, what is the biggest amount of area you can have with the wire given? So this is a little diagram. This is the house wall, and this is the wire that we're laying out. Okay, and so then we wanted to make an equation so we can work with it. So we know that these three sides equal 350, so we have 350 equals, and then we have two x's, so we made that 2x, and we have one y, so we made that. And next what we want to do is put one variable on the side to solve for that variable. And so in order to do that, we want to isolate the y. So we were able to do that by doing minus 2x. Then we have 350 minus 2x equals y. Okay, so then we know y equals 350 minus 2x. And so the next step, so we know the area is x times y, and so we can plug that y into the x times y. So then we have x times 350 minus 2x. You can simplify that a little more. So you need 350 times x, 350x, and then negative 2x times x is negative 2x squared. Okay, so this is our equation. This is the equation that we'll use to find what the maximum area is. So the next thing we want to do is find the critical points to find whether the maximum or minimum. We don't necessarily know yet which one it'll be. Okay, so we find the critical points. So we need to do the derivative. So the derivative of 350x minus 2x is 350 and minus 4x. Solve for x. We could subtract the 350. So 350 equals negative 4. Negative 350 equals negative 4x divided by negative 4 on both sides. That equals 87.5 equals x. Okay, so we know x equals 87.5. We don't necessarily know if that's a maximum or minimum yet, and the way to figure that out is to do the second derivative test. So with the second derivative test, second derivative of this equation right here. So the second derivative of this equation is just negative 4, right? And the negative 4 means that it's a concave down, and we know this because a negative, you know that negative means down, so concave down. And concave down looks like this, right? So then there's a minimum right there. So we know that there's concave down at 87.5 equals x, which means that there is a maximum. This tells us that for the max area to occur, we need x to equal 87.5 feet, but that's not what the question asks. We want to know what the maximum area is. And so in order to do that, we just plug the 87.5 feet into the x. And so we plug it into this equation right here. So 350 times 87.5 and minus 2 times 87.5 squared. That all equals 15,312.5 feet squared. It's the area, so the label will be feet squared or square feet. And if a question ever asks for this, I just wanted to go extra because I know it's important to know. If they asked us what what y equaled, since we only found what x really equaled, we could plug the x into the equation where the y was isolated. So the y isolated equation is this one right here. So we could plug the 87.5 into that x. So 350 minus 2 times 87.5 x. 350 minus 2 times 87.5. Equals y. That would equal 175 feet. So if it asked us what y is, we could see that it's 175 feet. But our final answer for this problem up here, specifically 15,312.5 feet, is the maximum amount of area we can get from only 350 feet of invisible fence wire.